In VLSI design and technology, experiment number 7, static RAM cell designed by transistor. In this diagram, in static cell, in this particular of the SRAM cell contains here P channel MOSFET, here N channel MOSFET, here P channel, here N channel MOSFET. This P channel MOSFET source terminal and this P channel MOSFET source terminal means M2 and M4 transistors source terminal, here VDD supply, and NMOS transistors, here ground side, source is connected to the ground. This MOSFET M3 source connected to the ground side. Means this is one inverter and this is another inverter. Here your data input is applied here. Data input is passed through this NMOS transistor. This NMOS transistor gate input logic 1, and this output is logic 1. This logic 1 input you applied here. This logic 1 input is applied to the inverter. Inverter's output is logic 0. This logic 0 input is applied to this inverter. Again, this inverter's output is logic 1. Means here logic 1 continuously stored in this particular of the circuit diagram. This is called as static RAM cell. And after that, this logic data you out through these N channel MOSFETs. N channel MOSFET gate input is logic 1. Then this N channel MOSFET pass this logic 1 this place to this place. After that you connect one inverter here. Then that inverted output you got at another location. Okay. So here this is working of SRAM cell. And in this SRAM cell, layout of this SRAM cell, here see this inverter N well contain P plus material. This is source terminal, VDD supply, drain terminal connected to the this another N channel MOSFET's drain terminal. N channel MOSFET source terminal is connected to the ground. Here another inverter N well P plus material, source terminal of P channel MOSFET VDD supply, drain terminal is connected to the drain terminal of NMOS transistor. Here polysilicon, here polysilicon gate. This input, data in input is applied here, and this input is applied to the gate of or input of this inverter. This inverter's output is connected to the this inverter's input according to this previous diagram, and this inverter's output is passed through this NMOS. This is NMOS transistor. A NMOS transistor here N plus material and polysilicon material, polygate, VDD supply is applied on gate. Means this NMOS transistor is continuously on. This logic is passed through this inverter, and after that data out. Means data in input is logic 1, so data out also logic 1. Here logic 1 input is applied here. Then this inverter's output is logic 0. This logic 0 input is applied here. Then this inverter's output is logic 1. Okay. And after that, this logic 0 pass through this NMOS transistor and input of CMOS inverter. Then CMOS inverter's output is logic 1. Okay. Data in, you store data in this static RAM cell, and after that read data through this inverter. Here data in input is logic 1, the data out is logic 1. Data in input is logic 0, then data out is logic 0. Okay. Here P plus material, N plus material, metal, polysilicon and contact. According to that, here using microvent software, you perform this practical. Okay. After that, I will explain here design rule. Lambda design rule is very important. The lambda is a half of feature size, and feature size is a channel length. Here feature size is a change foundry to foundry. When you fabricate your IC in foundry, that foundry rule is a lambda design rule. Here one example, N well. In this N wells contain P plus material. This P plus material width is 4 lambda. Here blue color metal width is 4 lambda by 4 lambda, and contact size is 2 lambda by 2 lambda, and polysilicon width is 2 lambda. Okay, in NVL, this space is 6 lambda, this space is 6 lambda, here 6 lambda, here 6 lambda, and distance between polysilicon and metal is 1 lambda, here also 1 lambda. Okay, using this rule, you design your CMOS circuits. Here, metal to metal spacing is 4 lambda. Here, this metal and in this metal again spacing 4 lambda. Width of metal is 4 lambda, and polysilicon in the two polysilicon distance is 3 lambda and polysilicon width is 2 lambda. Actually, polysilicon means gate length of this gate of MOSFET, and lambda is a half of feature, which actually lambda is a half of feature size, and feature size means channel length. Okay, and hence this polysilicon width is 2 lambda. Okay, so this is lambda design rule, and this SRAM cell you implement in uh, microwind software. Okay, here I will explain this microwind software. Okay, using microwind software, in this microwind software, okay, here actually एक minute, this circuit of SRAM cell. In this SRAM cell, CMOS inverter, here also CMOS inverter. After that, here in between this CMOS inverter and CMOS inverter, NMOS transistor, your data in input is applied here, and data in input is applied, suppose logic 1, then this inverter's output is logic 0. Here logic 0 input is applied on input of this inverter's output is logic 1. Means here logic 1 is continuously stored in this SRAM cell. After that, this logic 0 pass through this NMOS transistor here, and this logic 0 input is applied to the CMOS inverter, then CMOS inverter output is logic 1. When data in is logic 1 here, so data out also logic 1. Here data in input is logic 0, then data out is logic 0. This CMOS inverter he uh, change this particular logic 0, here output is logic 1. Actually here logic 1 input is applied and this logic 1 is stored, but this CMOS inverter output is logic 0, and that logic 0 is converted to the logic 1. So data in logic 1, data out logic 1, data in logic 0, data out is logic 0. Okay, you run this program and then you observe here uh, this input logic 1, then data out also logic 1. Input data in 0, output also 0. Logic 1, here logic 1. Here 0, here 0. We store the input data is logic 1. Logic 1 is stored in this SRAM cell, and then out data logic 1 and logic 0. Okay. So this is experiment number 7.